Welcome back to polynomial functions. We are going to look today at synthetic division. So we just came off of looking at polynomial long division, which was useful, but it also takes up a fair amount of space. Like as we saw here, to do an operation like this takes like a decent amount of room, and you have to write a lot of things. Synthetic division is useful because it saves us a lot of room and time. And instead of actually writing the like x cubed, x squared, x, and constant term, well, I guess constant terms stay the same. But we only look at the coefficients. Now this only works for dividing a binomial of the form x minus a. So there's no coefficient over here. So if you want to divide something, some polynomial, and divide it by 2x minus 1, that doesn't work because of this 2. But if you want to divide something by like x minus 3, or you want to divide by x plus 4, or anything of that kind of form, where the coefficient of x is 1, then you're good to go. Now, as with long division, we do need to make sure that there's a term present for every single degree from the highest down all the way to 0. So all those terms are present. So if we have something with degree 3 that we're talking about, say, like x cubes involved, we have to consider how many x squareds and how many x's and then how many constant terms as well. And then in descending degree still. So from 3 to 2 to 1 to 0 in that order. That's all necessary. There are some instructions on this page on how to do it. Let's do this together. So we're going to divide this polynomial, 4x cubed minus 49x plus 60, and we're going to divide that by x plus 4. The first thing that you want to do is write this stuff here. So what we have over on this side, this 4, this 0, this negative 49, that's 60. Those are all the coefficients of our terms in our dividend. So this 4 is how many x cubes we had, because there was 4x cubed. We had no x squared. There's no x squared term here, so that's all sad. But we account for its presence with that 0. That's how many x squares we have. We have this negative 49 because of this negative 49x. So that's how many x's. And then the 60 is how many constants we have, how many ones. This 4, where does that come from? That's from taking this 4 here and dropping it over there. Now, we're going to be, using subtraction to get all of our values down here. And our values down here are going to be our quotient in the end of things. For startsies, there's nothing here. So we're just going to straight up drop that down in a different color. And that's what, I guess I can just bring that here. And that's why we have a 4 at this point. To get what goes here, 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 we're going to be doing alternating multiplication and subtraction. So we're going to take these two terms and we're going to multiply them to get 16. So by multiplying those two terms, we get 16. From there, we'll be subtracting again. So 0 minus 16 is going to get us a value here. We're going to multiply that by 4 to get a value there. And we're going to keep doing that. We're going to subtract, we're going to multiply, we're going to subtract, we're going to multiply. So as we look what's down here, 0 minus 16 is what gave us this negative 16. Negative 16 times 4 is what gave us this negative 64. Subtraction again, negative 49 minus 64 is what got us this 15. And now multiplication again, 15 times 4 is what gets us this 60. And then 60 minus 60 gets us 0. So to get to this term is always a multiplication, and then to go this way is always subtraction. And then this way there's a multiplication, this way there's a subtraction, this way there's a multiplication, this way there's a subtraction. Just over and over and over again until we have this last spot filled. In this case, it's a 0 at the very end, which actually tells us there's a 0 remainder. But what does this whole business, you know what, I could actually keep that. But what does all this business mean as we look at it? Like what do these 4, negative 16, and 15 represent? In the end, so 0, this last term here will be our remainder. This term here will be how many 1s we have. This here, this next one over where the negative 16 is, will be how many x's. And the next one over, we're just going ascending degree here, so it would be x squared. And by that, we get an answer of 4x squared minus 16x plus 15, with a remainder of 0, if you want to say that. We've got a few examples to go through. First 4 will just be using synthetic division to actually determine a remainder. So our goal will really be to figure out this end value there. And then there's one more example of just straight up dividing and saying what the answer is. So let's not dilly-dally, let's just get right into it. Switching to purple, of course, naturally. So we're going to use synthetic division to determine the remainder here. Okay, I can do that. So setup-wise, we've got x squared. We have the x squared term, the x term, and the constant term. So those are all accounted for. And I can say that we're dealing with a 3, a 2, and a negative 12. And when we divide all that, we're dividing by x plus 3. So I'm going to stick a 3 right over there. I'll indicate that with a different color though. So that's that. And now we're going to subtract as we go this way. We're going to multiply as we go this way. 3, we're subtracting nothing from it. So that's just straight up 3. To go here, we multiply. And that's 3 times the 3 that's over here, which gets us 9, if I know how to multiply. To go down, we subtract. So 2 minus 9 is negative 7. To go up here, we multiply. Negative 7 times 3 is negative 21. And then to go down again, we're going to subtract again. So negative 12 minus negative 21 is 9. So remembering that what these tell us is that this last number here is the remainder. This is how many 1s, and then this 3 is how many x's. All we're concerned with in this case is the remainder itself. So we can just say that the remainder is 9. Try out the others, see how they go. If you need to see them done, then keep watching. But I encourage you to even just try one, try it in pencil if you want. So if you're not feeling optimistic about it, at least you can erase. I mean, sure, you can white out with a pen too, but follow your heart. I'm just going to straight up do these other ones, and then there's an example after these ABCD to just straight up divide. Here I go. Ooh, what color did I use? Purple. I have 1x to the 4. I have 0x cubes. I have 0x squareds. I have negative 5x's and then minus 9. And I'm dividing all that. Oh, I could do a straighter line than that. By x minus 2. So again, it's this negative 2 that's coming there. And that this is how many x to the 4s, how many x cubes, x squareds, x's, and 1s. So I've got to make sure those are all accounted for. Absolutely necessary. huge part of this. Blue, sure. 1 to go down this way is subtraction. 1 minus nothing is 1. As I go up here, that's multiplication. 1 times negative 2 is negative 2. To go back down is subtraction. 0 minus negative 2 is positive 2. To go back up is multiplication. 2 times negative 2 is negative 4. To bring that down is subtraction. 0 minus negative 4 is positive 4. To go up, multiplication. 4 times negative 2 is negative 8. To go down is subtraction. Negative 5 minus negative 8 is positive 3. To go up is multiplication again. 3 times negative 2 is negative 6. And to go down is subtraction. Negative 9 minus negative 6 is negative 3. And as a reminder, pink, no purple. This is the remainder. This is how many 1s. This is how many x's, how many x squared, and how many x to the cube, x to the 3's. For this question, all we're concerned with is the remainder. That's all that was asked of us. So we can say that the remainder is negative 3. Continue to try these other ones, and I will just dive in here. We've got 3x cubed, negative 5x squared, we have 1x, and, oh wait, this actually be there, there we go. And then 0 for the constant term. And we're dividing that by x plus 1. Let's bring this way, subtraction. That's multiplication. You do not have to write these, by the way. I'm just indicating them for the sake of the notes that, I don't know, you can have a reference as to what's going on if you're just trying to follow it along, but you don't have to write them. Subtraction should be negative 8. Multiplication, negative 8. Subtraction, 9? Sure. Multiplication, 9, and subtraction, negative 9. And we can say that this is the remainder. This is how many 1s, how many x's, how many x squareds. Again, not necessary to write those, as long as you are aware of what's what. But if you're not sure, then maybe label these, and that could be helpful to you. The remainder in this case is negative 9. And last one of these, we're going to take 1x to the 5, negative 2x to the 4, negative 8x cubed, 0x squared, 0x, and 7. Again, making sure everything is accounted for. And we're dividing by that by x minus 4. And I'm going to go through this process again. I'm not going to write all the arrows this time. I'll expect that you kind of know what's going on at this point because we've now done it a few times. But check out the other ones if you do need that reference. So I'll describe it with my words out loud with my mouth parts. So 1 minus nothing is 1, that just straight drops down. 1 times negative 4 is negative 4. Negative 2 minus negative 4 is positive 2. 2 times negative 4 is negative 8. Negative 8 minus negative 8 is 0. 0 times negative 4 is 0. 0 minus 0 is 0. 0 times negative 4 is 0. Okay. 0 minus 0 is 0. And 0 times negative 4 is still 0. 7 minus 0 is 7. So remainder, these are 1s, are x's, x squared, x 3's, x to the 4's. Boom. So our remainder in this case is 7. Final example is to straight up divide. Oop, there it is. So we're just going to do that by you can, whenever you're given if you're given a question like that, you don't have to use synthetic division, but it will be faster. So if you're comfortable with synthetic division, use it. If you're more comfortable with long division, use that. Whichever one you think that you can do more accurately. Right? If your end goal is to get the most marks in the shortest amount of time, whatever is going to allow you to do that is what you want to play with. In any case, here I go. There's 3, 2, -1, and 9. I'm going to be, sure, good enough. Dividing that by x plus 2. So again, won't be describing all my down and up things. I'll do it with my words. So 3 minus nothing is 3. 3 times 2 is 6. 2 minus 6 is -4. -4 times 2 is -8. -1 minus -8 is +7. 7 times 2 is, what am I doing? 14. And 9 minus 14 is -5. Again, remembering that this is the remainder. This is how many 1's, x's, and x squared. So when we put this all together in our final answer somewhere, we will say, I was going to write it up here, but I'm going to write it down here instead, that 3x cubed plus 2x squared minus x plus 9 divided by x plus 2 is equal to, so let's take a look at this part. So not the remainder at first, the actual quotient we would get would have 3x squared minus 4x plus 7, and then accounting for the remainder, using that same kind of remainder format that we had in the previous lesson, we'd say we're losing 5 over, what are we dividing by? X plus 2. And we can say that these two things are equal as long as x isn't equal to -2, because that would do dirty things to this denominator. We don't want to do that. So that's the dealio there. So just noting that we took this part, and that's what became this part. And this thing is what brought us there, giving us, yikes, this final answer. There is a little bit of practice work for you down here at the bottom. It's not a whole bunch, but just give it a try. See if you can familiarize yourself with synthetic division. We're going to be doing like a fair amount of dividing polynomials as we proceed. We do have a couple steps more to get to the point where we're putting everything together, but get some comfortability with synthetic, or just make sure you are very 100% secure with some method of polynomial division. Synthetic or long, up to you, follow your heart, but make sure you have a way to do it and to do it quickly. If you do have questions, comments, concerns, please do not forget to ask either in class or via Teams, either questions on this lesson itself or questions on any of the work that you are doing. Do make sure that you're getting those questions addressed so that I can effectively help you. That's all I have. May you have a lovely life forever.